I'm Michael, and I'm here today to speak with Stuart about sustainable water management in the built environment. In Australia, we've had a difficult run with droughts and bushfires and some flooding, and now the coronavirus. And we're conscious that, water management, we think we need to change the conversation a bit.
I think that's exactly right. And what we've learned here is, in terms of resilience and the built environment in particular, is that the design of buildings has a huge part to play in the way that cities operate, and in regards to being resilient to changes in the environment, external factors there. So we know that buildings have the ability to reduce consumption, minimize the impact, and that cities operate in a system of lots and lots of small pieces all fitting together. So we want to look at that and how each building can better perform. So I'd like to explore this a little bit more. Michael, can you cover quickly what we're going to be talking about through this session?
Thanks, Stuart. So I think you really covered it, but to summarise, we're going to be looking at sustainable water management, what that means, the urban water cycle, so how urbanisation changes the way water moves through our environment, and the role that buildings play and should play in the cities of the future.
Thanks, Michael. Can you maybe just elaborate for us a little bit on what we mean by sustainable water management? Because I think it may be something that's not a universal term.
So we had quite a conversation within the office, and when we started to explore it, we realised that there's, if you like, different levels. So there's some basic concepts around using, for instance, water efficient appliances that might be required under building regulations and plumbing regulations. But you can go further than that, and you can use, higher technology water efficient appliances. Then there's a whole field around the behaviour within the house, so how people use water appliances. Do people switch the tap off whilst they're brushing their teeth? That kind of thing. And then from a design point of view, the way you design the house will actually influence the water a lot. So if you've got a lot of lawn area in a warm climate, then you're going to use a lot of water. Swimming pools use a lot of water through evaporation and splashing, etc. So some of those basic design features will have a big impact on how much water you use. There's a key area for us is around harvesting rainwater, and you can do that at a minimal level and have a rainwater tank and water a garden, or you can be a bit more sophisticated about it and run a well-designed system which you can then use to flush toilets and to do your clothes washing with, and as well as the garden, and that makes a big difference, and obviously the size of the rainwater tank and those sorts of things. Recycling is a big issue. So there's much more high-tech solutions around using some of those less polluted wastewaters and treating them and then feeding them back into the cycle, either at a house level or at a municipal level. Then I suppose the most interesting area, which is at the building scale and at the neighbourhood scale, is the whole idea of water-sensitive urban design. So managing your buildings and your landscape so that they're retaining the water that falls on them, using that water efficiently and reducing negative impacts on the surrounding environment. So it's a whole scale of thinking. And then wastewater, of course, too. Sorry.
Wow, it sounds like there's certainly a lot more elements and a lot more factors going on. You use the word system quite a lot in there. I'm wondering if we can sort of compare that to the traditional urban water management and the way that cities were thought of at a utility scale, and the way that things are still being put together for infrastructure in a city, because it seems quite different.
So I think it's important to understand the way we look at our cities and water management in our cities now, and it's really based on a very important development back in the 1800s in industrialising England. Edwin Chadwick talked about a radically new way of managing water, which involved piping water in from clean reservoirs around the city, and then piping wastewater and sewerage out of the city to be treated elsewhere. And he had a very strong health focus. He was very concerned about the health impact on the people living in London. And it's been a very successful model in terms of it's been used all around the world, and it has become our understanding of water management. And it's very good so far as it goes, but we're now seeing a lot of challenges in our cities that we need to address that aren't covered by that model. So it didn't consider things like the rainfall that was landing on the buildings in the city and how we might use that. It didn't really consider the whole issue of stormwater. They just included stormwater in their wastewater management, which has created another set of problems for their creeks and rivers. So we think we need to change that language a bit. We need to be talking about a system, an urban water cycle that's happening, more discussion about the impact on the natural environment, and then obviously how buildings become part of that. And in order to understand the important role of buildings, we really need to look at how an urban area changes when it goes from a natural landscape, which is mostly grasses and forests, to a built-up environment. And it's interesting to look at the numbers here. So in a more natural landscape, the landscape retains about 80% of the water. And that either becomes groundwater, it infiltrates into the soil and becomes groundwater, or it evaporates and has a cooling effect, but it also becomes water vapor and can land again as rainfall. When we urbanise, we see a very big shift. Instead of 80% of that water being retained, 80% of the water becomes runoff. So it very quickly runs off that landscape. So we have quite negative impacts on our waterways. We see flooding, and we see scouring and a loss of that ecological habitat. But we also don't see groundwater. So the base flow, when it's not raining, we see a lot less flows in those local waterways. And we also don't see the levels of evaporation and evapotranspiration that have a really important cooling effect for our cities, but also create more rain. So, one of the ideas that we start to talk about is that our cities are becoming deserts. We're seeing less rainfall, they're getting hotter and windier, and when it does rain, we're seeing flash flooding. So it's a pretty negative image, but it's one that we need to think about. And the great thing is that buildings can then become part of the solution and address all of those impacts to replicate that natural environment.
That's a great segue. Thanks, Michael. So if we did want to take a look further at the buildings, I think it's worthwhile to take that thought that buildings are part or can be part of the solution rather than part of the problem. And that by changing the way that water is managed at an individual scale at a single building or in a suburb or a town or at a wider scale, we can actually change the impact of a whole city and a built environment on the natural environment. So we see an example of this where we're using now a lot of decentralized solar PV to generate electricity. So we don't need to rely on a great big infrastructure solution, and we can get small inputs coming into the system in the local area with less transportation and less infrastructure required. We can use our buildings and think about our buildings in three different ways. The first being that we make them more efficient than they were before, so they consume less inputs from the external world, and that's things like insulation from a power and heating, cooling costs there. But in a water sense, it's things like water efficient appliances, shower heads, taps, washing machines, things like that. Then we can also think about generating ourselves, so generating energy or water at the site, and look at an individual building and how much it can actually bring in through solar electricity and through rainwater harvesting as examples. And then lastly, changing the processes in the building so that we reuse as much as we can. And again, things like insulation, but in a water sense, maybe small recycling, reusing water that might otherwise be pumped away into wastewater and reusing it on site for irrigation, for example. So with these things in place, we can actually end up with a building that has a net positive effect. It's actually generating more than it's consuming. And you think about that in terms of rolling that up into a city scale, the buildings can actually make a massive contribution to the way a city is performing.
Stuart, one of the things that I'm hearing about a bit is this idea of a crisis, so that there's a sense of urgency around some of these issues and these changes. Do you think that there is a crisis? Is that something we're looking at?
I think you don't have to look too far to see examples of the impact of the climate on cities, and in particular hot, dry summers and a shortage of utility water supply. And we've seen notable examples in Cape Town and Atlanta in the last few years where whole cities of millions of people have been running short of water. And then At the same time, we get stories about whole cities having enormous amounts of floods and extreme weather events leading to peak flow of stormwater and flash flooding. Both of these are very damaging problems and seem to be coming up more and more frequently in the last 10 and 20 years. Particularly what we know about the flooding situation is that it's a massively expensive problem. Floods are hugely damaging for cities, and we're seeing impacts there in the insurance industry where it's no longer cost effective or available to get insurance in some situations because the risk of flooding is too great and the cost associated is too much.
It's interesting, that's become part of the conversation in Australia. So some of the consultants are talking about 1 in 10 houses not being insurable by 2030 because of a combination of a whole lot of things, not just water, but a number of them are water related. So Stuart, we've spent a bit of time covering theory. I think it would be good to talk about some practical examples of what's been done around the world in terms of using water more smartly, using the design of the buildings to get into this idea of circularity and minimising the impact. Can you take us through some practical examples of this?
Yeah, excellent. The first one we want to talk about is a recent renovation and development of a library area in Marrickville in Sydney. So this is an older heritage building that was renovated as part of a development site where they've increased density and built some medium density apartment buildings in there. So the existing heritage building was renovated and upgraded and turned into a public library. And here in the picture you can see in the courtyard next to the library they've installed 6 large Kingspan rainwater tanks. This is an iconic Australian corrugated steel product in an Australian native landscape garden there. The 6 tanks storage about 57,000 litres, capturing water from the roof of the library and filling up those tanks there. And then the water is reused into the public toilets and facilities inside the library there. So these 6 relatively small tanks have the ability to save about 400,000 litres of water a year that would otherwise have been piped in from a dam many kilometres away. So it's a really great example of using the water, reusing the water on site where it falls without having to treat it and without having to pump it long distances. This site also, when these tanks are overflow, which they do a few times a year, the water from that runs into an underground stormwater retention basin and is further slowed down and treated before it's let into the stormwater network. So it's quite a good integrated system there, and we've got a really visible example of using rainwater where it doesn't need to be hidden away, and it's part of a feature of a landscape garden as well.
Yeah, it works well.
The next example is a little bit smaller scale, but this is a London townhouse, and this is an architect owner who's renovated the house and trying to be as sustainable with all elements of the design of the building. So this house, 4-storey terrace house with a relatively small roof area, they're capturing the whole roof area into a 1,200 litre Kingspan rainwater tank underground in the backyard. And then they transfer the water up into a header tank in the attic space, and then the water is released by gravity down to flush the toilets through the whole building, and I think used for some irrigation in the gardens as well. So this is a really compact lot scale example of stopping the rainwater from leaving the site, reusing it through the appliances in the building, and just minimising the impact of that development on the natural environment.
Stuart, I'm curious on something like that. Are we talking very technical equipment? Is it a very expensive installation?
No, that's a pretty straightforward installation. They'd have 2 small tanks there and 1 small pump, and quite straightforward and quite commonplace now to be able to be done on a residential lot without a huge impact on cost as well.
Yeah, cool. I've got one that I wanted to talk about. It's the library at the Queen's University in Belfast. So it's quite a large space. They can manage a couple of thousand students there. They talk about an amble area where you can look at 1.5 million books. which means that it covers a fair amount of area and has quite a large roof space. And there was a very strong sustainability focus from the building designers. So they've utilised this roof space by capturing the rainwater from it. They capture about 2.5 million litres a year. That goes into an underground tank, and there's a fairly simple filtration process, and then they run that back through the toilet. So it's, again, an example of building into the initial design smarter ways of managing water, rather, as you said, rather than trucking in many kilometres from another centre and treating it to a very high level, then becoming part of the sewage system.
The next case study we wanted to look at was some townhouses where the water tanks are actually required to help reduce the stormwater impact of this development on the local creek that's nearby to the development. Michael, this one's in Pascoe Vale in Melbourne. Would you like to tell us a bit about this?
Yeah, so this is interesting. Local government has really taken on this idea of particularly stormwater management and using rainwater harvesting for stormwater management. So this isn't a one-off. This is part of the whole regulatory framework of this particular local government area. They have, there's 21 residences there, and they've installed a relatively small 1,500 litre tank in the garage space underground of each of these developments. And that, although quite small, is sufficient to deal with most of the small rain events that occur on that site, and has a really important difference to the quality of the water coming off it and the volume of the water coming off it in terms of local waterways and reducing the impact of local flooding. So they capture about 75% of the roof area into those tanks.
That's excellent.
So Stuart, we've talked quite a lot about the design of buildings. Kingspan have been in this space for a long time. Can we talk about some of the stuff that we do that can improve the impact that buildings have on our environment?
Yeah, absolutely. So I think we've talked a lot about rainwater harvesting, and Kingspan is a major manufacturer of rainwater harvesting products. So we produce a range of above ground and below ground rainwater storage tanks, as well as some quite large storage tanks for more industrial and agricultural purposes. We've got a range of storage tanks then in the agricultural space for fertilizer and fuels as well. And in the water space, more generally, we've got integrated underground systems for stormwater and also for pump stations and water transfer. And then we've got some specialized stormwater products for separating oil and other particles and things out of stormwater networks. We've also got a wastewater treatment product, which is industry leading for treating on-site wastewater.
Actually, on that, I've been looking at some material and a really interesting design solution. So it's I think it's an old church with a restaurant and two artisan studios, but it's set in these beautiful grounds, which are obviously environmentally quite sensitive. So they needed a wastewater solution that didn't have a big impact, and they also didn't have good access to the site. So there's a helicopter bringing in one of our biodisc systems, and it's really quite nice, I have to say.
Okay, well, Kingspan this year has launched a massive initiative called the Planet Passionate. This is a 10-year program for initiatives in climate. So it's really to address three major global themes on the environment, being climate change, circularity, and the protection of the natural environment. So it's really exciting for us to be part of this program and to really be involved in it. In particular, one of the targets is around rainwater harvesting, and the target we've set is that in 10 years we will be saving 100 million litres of water a year through rainwater harvesting on Kingspan facilities. So at the moment there's over 100 buildings that Kingspan owns around the world, and we've already started to install rainwater tanks on these buildings.
I've been in this industry for quite some time, and I've not heard of a world program like that before. So, it's exciting to be part of something that's quite ambitious. The water theme is continued also. We're quite concerned about the oceans, and we've joined with a not-for-profit group called EcoAlf. and they're working with fishermen in the Mediterranean to retrieve a lot of plastic waste from there. We're looking at up to 150 tonnes a year. So we're going to be doing that, and we're also looking at doing 4 ocean cleanups by 2025.
Wow, thanks, Michael. That sounds like a huge project. Just to talk about some examples of the rainwater harvesting target on Kingspan's own building. So just firstly, we want to look at the Icon building in King's Court. This is adjacent to the Kingspan Group headquarters there. So recently developed this new building using a lot of Kingspan's own products as a showcase of the kind of design that's possible now using modern building materials. And as part of that design, we've installed rainwater tanks in the basement of the Icon building, and those tanks capturing the water from the roof of the building and reusing that through the toilets in the building. So just to showcase exactly what's possible on a nice, neat, architecturally, I think quite good looking building in a country scape in Ireland. The Kingspan Water and Energy Facility in Rocketnica in Poland has also already installed rainwater harvesting tanks there. So in that situation, they got a 20,000 litre tank connected to about 3,500 square metres of factory roof area. So there's enough roof area there with even modest rainfall in that region of Poland for them to refill that tank, I think about 80 times a year. Again, that water is being used back into the toilet block in the building, so all that water is reducing consumption of the mains water that was otherwise being used. Thanks, Rod. Just to summarise then, what we wanted to cover off here was talking about sustainable water management and just making sure we have a clear understanding of what is meant by sustainable water management. Also really understanding the urban water cycle and trying to change the conversation around what an urban water cycle is, and understanding that it's more than just a centralized infrastructure, and there are a lot of inputs and outputs and varying factors on an urban water cycle. And lastly, probably most importantly, the key to an urban water cycle really is the buildings, and that it is possible for buildings here to be part of the solution and not just the problem.
Excellent.
Thanks very much.
No worries. Thanks, everybody. Cheers.
Bye.